Okay, guys, to solve problem number 2, you're going to need to use the work formula. And so I'm just going to remind you that's work equals force times distance. And you know the force, and you know the distance traveled. The only force acting on this situation is this force, the force of friction. So we're going to put that in there. Force of friction equals 2.5 newtons, and the distance traveled equals 1.2 meters. So then you just have a simple multiplication problem, 2.5 times 1.2, and that's going to give you the work done is 3 joules. Start with that, and then we're going to get to part 2 here. Okay, we're starting with part knowing the work done. The net work, or the total amount of work done, equals the change in kinetic energy. Yeah, so it's kinetic energy final minus kinetic energy equal, or initial. Now, the final kinetic energy is 0. So the total work done is whatever it is. We're just going to call that W. And we know what that is. That's 3 joules equals 0, because that's the final kinetic energy, minus the initial kinetic energy. And the initial kinetic energy is, to get initial kinetic energy, that is just the kinetic energy formula. And you know that. That's kinetic energy equals 1/2 mv squared. So we know the mass, and we know that 1/2 is equal to 1/2. So we can use that to solve for v. All right, so let me just kind of march this out here. So to kind of summarize you again, work that we calculated before was 3 joules, and that equals the change in the kinetic energy, and the initial kinetic energy is all we have to concern ourselves with because the final kinetic energy is 0. So 1/2 times mass, which is 0.75 kilograms, and times v squared. And I'm going to square that. There we go. Now it's just an algebra problem. You are solving for v. So 3 joules divided by 1/2 divided by 0.75 will give you v squared. Get the square root of that to calculate v. And the question is, that's what you're asking for. Find the book's initial speed. That is velocity. All right, go be awesome.